All right, here we go. Day 2, systems of inequalities. All right, so we did these yesterday. Let's start off. I'm going to do number 5. So, is it in slope-intercept form? No. Of course, we need it best in slope-intercept form, so we're going to get it there. So, get y by itself, add the 2x over here. This one's pretty easy to do. You would just subtract 2x from both sides. Sorry, typo. Graph your lines. What's the y-intercept? What's the slope? Solid or dotted. Graph the other one. The same intercept, -2 slope, dotted line. So, graph your lines. You should be pretty good at graphing lines by now. Now we need to figure out where our shaded, our double shaded region is. So the first line, this one here, is below. So I am below the first line. Second line, I am above the second line. So my double shaded region is that part over there. Again, lightly shade and then figure out where your overlapping part is and shade that in heavier. All right? So, one of the things you're going to be asked to do is I will give you a graph and you have to work backwards and tell me what the inequalities were. Okay? So now I can look here. Let's figure this out. It's not as hard as it sounds. So let's pick this line right here. What do I know about this line? 2 things. Remember back to when we wrote equations before Christmas, before break. I need 2 pieces of information. I need the intercept, I need the slope. Okay? On all of these, you should be able to see that information. What's the intercept? 2. What's the slope? Well, I can go down 1, right 1, and hit another point. So the slope, -1/1. So now I can write my equation. So for this first line, y equals -1x plus 2. There's my first one. But it's not an equal sign, is it? So this, right here, it's a dotted line. So that tells me what symbol. And then where's the overlapping? Where's the shaded part? It's a little hard to see, but this is the shaded part. So am I above or below? So what symbol is going to go in here? Dotted line below, that's a less than sign. All right? So let's do it here. What kind of line is this? So we know vertical lines are always in x equals some number here. Of course, we can see this one's going to be x equals 3, but it's not an equal sign. All right. It's dotted, so I know it's a greater than or a less than. Which side is shaded? Less than. So it's a less than sign. So I can look at the graph, see where the shaded regions are, and write my 2 equations. Let's do it again. Try and do this one in your notes. All right, so I've got this line here. I'm going to do this one first. You may have done the other one. I can see the intercept is 1. My slope, down 1, right 2. So that's -1/2 x. I am above the line and it's solid, so that's greater than or equal. To check this line, it's going to go right through there. A little hard to see, but it's going to go right through there. And I got a -3 slope. It's going, here's my next good point. So I'm going up 1, 2, 3, 4, right 2. Or I could have done this one, up 2, right 1. Same thing. It's a +2 slope. I am shaded above the line. Nope, wrong line, sorry. Here's my line. I got a little confused. I am below this line because I'm down underneath this line and it's solid, so I'm less than or equal to. So you can work backwards to write your inequalities, okay? Pay attention to the things you know. You know your intercepts, you know your slopes, solid or dotted, above or below. Okay, everybody's favorite word problems. Just read carefully. You need to know, and we have talked about it a long time ago, phrases like this, at most. Does anybody remember what at most means? Less than or equal to, because that's the most I want to spend. I can spend less than that, but that's the most, okay? And then the other important phrase that you need to know is at least. Spend at least. At least, well, that's the opposite, so at least means greater than or equal to. Write those in your notes. You need to remember just those two phrases. Just write them down. They pop up in these word problems a lot. So, you have at most 8 hours to spend at the mall and the beach. And, so that's together. So right now, I've got mall plus beach is less than or equal to 8. First sentence tells me that equation. You want to spend at least 2 hours in the mall. So that's greater than, so mall is greater than or equal to 2. And more than 4 hours at the beach. So the beach is more than, it doesn't say equal to, it just says more than 4. So now I've got 3 equations. That's fine. Since we're dealing with time, I know I only need the upper quadrant, right? Because everything's going to be positive up here. I can pick whichever axis I want to use. I'm going to call this mall, this beach. So, mall plus beach is less than or equal to 8. Now, how can I graph that? Well, I could get it in slope-intercept form, but I don't know which one's y and which one's x, right? It's kind of hard to figure out. Intercepts are going to be helpful here. I can still use my intercepts. I can find my m-intercept and my b-intercept. Remember, to find intercepts, I plug in 0 for the other variables. So if I want to find the m-intercept, I plug in 0 for b. Well, m equals 8. If I want to find the b-intercept, plug in 0 for m. b is 8. So my intercepts are 8 and 8. It's got a line underneath it. So I got a solid. M greater than or equal to 2. So my m, here's my 2. Right there. B is greater than 4. So, where is my shaded region? Well, I don't want to make this look too messy, all right? But I've got less than this line. I've got greater than 2. And I've got greater than 4. Which part of the graph hits all 3 regions? Well, that triangle right in there. Hits all 3 regions. So if I pick some amount of time in here, so I'm looking at something maybe right there. So that would be mall is 3 hours. Beach is 5 hours. That point right there. Because that gives me my 8 hours total, because I can be equal to. That gives me more than 4 and more than 2. So there, by using the shaded region, I found an acceptable answer. All All right, so we have 3 graphs on the same thing, and you find where all 3 overlap. Next. Just for a quick refresher, can you pick an ordered pair that is a system, a solution to all of these systems? Okay, can you pick an ordered pair that is not a solution to all of these systems? All right, just a little check for understanding there at the end. Take your time, ask questions. Good luck.